syllabus of this unit. So now let's get back to the topic which are there in unit 3. First, introduction and classification of materials. So in any manufacturing
सर
of a product, yes.
सर चैप्टर का नेम क्या है?
चैप्टर का नेम the study of plastics and composites, unit 3, right? If you can see your
सर वो
syllabus,
मेंशन करिए ना वहाँ पे.
that that's why before starting of this PPT I just told you na, that is unit 3 is study of plastics and composites. Okay.
क्लियर नहीं आ रहा था वॉइस उस टाइम.
Okay. Your third unit is study of plastics and composites. Okay. So in that I already told you what are the syllabus, what are the topics are there in that unit, and in that first topic is introduction and classification of material. So before you manufacture a product, the raw material it is very much important, because from the raw material, by going through different processes, different applications, then that raw material is converted into a finished product. Okay. That's why raw material is a very much important part in any manufacturing or any material science or metallurgical science. Raw materials is very much important. So there are various types of classification are available in literature, in research. So material, generally materials you can classify in three categories, three basic categories. They are metals, ceramics, polymers. Okay. And a mixture of these fundamental types, a mixture of these basic categories, if you mix one or two, you will get a composite. This is the basic. Okay. Then first is material, metals, ceramics, polymers. Then again, it can be broadly, if you classified it, if you broadly classified the engineering materials, you can classify it in six categories, like metals, polymers, elastomers, ceramics, glasses, hybrid composite materials. Okay. So let's start. So this is the classification of engineering materials into six broad families. So if you see the metals, you will find that steels, cast irons, different types of alloys like aluminium alloys, copper alloys, zinc alloys, titanium alloys, many types of alloys are there. Then again from that we can have ceramics. Also different hybrid materials are there, different polymers are there. Okay. Then different ceramics, these, see these categorize, this is the its name, and these are few examples of that. Like ceramics, few examples are different alumina, silicon carbides, silicon nitride, zirconium. So all these are different examples of a ceramic metal. Then if we talk about hybrid metals, then we have different types of sandwich materials, composites, segmented structures, lattice, and different other things. Then if you see polymers, these are the few broad names are there. Here we just mention in short. Okay. Then from there, by mixing of like ceramics, hybrids, we can have again different types of glasses, like different borosilicate glass, silica glass, etc. Glass ceramics, etc. are there. Then if you add hybrids and with polymers, then we will have elastomers. Different examples are given here. Okay. So this is a broad way we can classify our engineering materials. In different way we can classify our engineering materials. So here we classified engineering materials in two categories. One is metals, another is non-metals. Again in metals we have ferrous and non-ferrous. Then different examples are given. Then in non-metals we have organic non-metals and inorganic non-metals. These are another way we can classify our engineering materials. Then these organic materials, you can again classify it in different ways. So here I just show you the related things with your syllabus. So in organic materials, it can again classified as polymers, and in different others type. In polymers, we have thermoplastic, thermosetting, and elastomers. Polymers can be classified as thermoplastic, thermosetting, and elastomers. These are the few examples of that category. Then in another organic materials, we have different types of carbon, wood, different types of fiber, leather. Okay, these are the organic materials. Then inorganic materials, it can be classified as ceramic, glass, and different other types. So these are the examples is given. Ceramic like alumina, magnesia, then nitride, carbide, etc. Then glass, silica, lead, etc. These glasses are there in another like mica, concrete, plasters, etc. They are the inorganic materials. Okay. So in your syllabus, we have like ceramic, then polymers. So here I just give you in short the few other the things. Okay, so these are the just a gist of all this. Like ceramics, what is ceramics? Ceramics are mainly are compounds. So in ceramics we have, or in this compound, we have a metallic and a non-metallic part. Okay, so ceramics is a compound, and this compound contain a metallic and a non-metallic part. Here in non-metallic parts we have oxygen, nitrogen, and carbon. So different examples of ceramics are carbides, silica, alumina, clay, etc. Then next is polymers. So what is a polymer? Again, polymers are compounds which consist of repeating units in them, called as mers. Repeating units, not in single unit, repeated. The units which are present there, they are repeated to make a special bond and to make special type of materials, which is special type of compounds, which are polymers. Okay. So polymers are compounds which consist of repeating units in them, called as mers. Polymers. So remember that. Poly, then mers. Poly means number, more. Mers is that small repeating units. So Mars share electrons to form very large molecules, usually of carbon and some other elements like oxygen, hydrogen, nitrogen, chlorine, etc. Polymers are further classified into thermosetting, thermoplastics, and elastomers. So later, when we will more broadly uh, go through the polymers, then we will able to have more idea what is polymers, how it make, what is the properties, features, etc. Okay. So polymers they can be classified as thermosetting, thermoplastics, and elastomers. So common polymers examples are PVC. PVC pipe you all know that PVC is none other than like polymers. It is only polymer. Then polythene, different plastic packet, polythene packet you find. There are different types of polymers. Next, just we told that ceramics are there, polymers are there, and composites. So what is composites? Composites consist of two or more phases of materials. Okay, in composites there are two or more phases of materials. The phases are processed separately and then bonded together to achieve properties superior to the constituents. Like alloy, like in alloy, what happened? Two different types of materials they come together and after mixing they make a superior product. So here also the composites are making a part of two or more phases of material, and this different phase they process differently. They you can make differently those phases of material. Then that phases they come together and bond, making a bond by using different processes. Then the purpose of this bonding is to achieve properties superior to the constituents. Okay, so in this, some of the materials used in the phases, or like here we told that composites consist of two or more phases of material. So some of the materials are wood, or you can say fiber, okay. And they some wood or fiber they homogeneously bonded or mixed with each other using different epoxy, and they make different types of composites. Okay, so composites why we make, to make more superior, to get more superior properties, to get more advanced properties than the existing one. Okay, like we have phase A and phase B. So if we mix this A and B, if we mix A and B phases, then we can get a new composite which can provide you more superior properties than individually provided by the A and B. So this is the reason, this is the application that due to which these composites are getting very much attraction nowadays in the research field, or we can say in the application of aircraft, different types of automobile sector, even sports, different health related issues. In those field, composite materials are getting higher demand. So first, in your syllabus, first thing is polymers. So you need to know what is polymer. We already told that. Here what we told, polymers are compounds which consist of repeating units in them called as mass. So a polymer, it is a large molecule or macromolecule composed of many repeated subunits. Many repeated small units they compose with each other and they make a large molecule or large macromolecule to form this polymer. So polymer, the name, it comes from a Greek word. In Greek, poly means many and mar means part or segment. Just I told you, poly means more than one, many, and mars means small part or small segment. So polymers are made up of many molecules which strung together to form really long chain and sometimes more complicated structures. Okay, complicated structure means complicated structures than those small segments. In general, those molecules how's its structure. If you join different molecules in a long chain, then in total their structure get complicated and they make very strong bond and they can make very hard resistive materials. So here if you can understand that the molecules which strung together to form a long chain, or sometimes they make a complicated structure. Okay, so what will be the properties of polymer? That depends on these molecules and how they are put together. They come together and how they put together to form those long chains. So how polymer will act or what will be their properties, that depends on what kind of polymers we are using as well as how they put together. These are the two things which decide how your polymer will act or how your polymer will react, what will be this application. Okay, so in basic terms, a polymer is a long chain molecule that is composed of a large number of repeating units of identical structure. So there again, please note it down that there are numbers of molecules. Okay, and that molecules they came together to form a long chain. Okay, and they make this polymer. So these molecules, always remember that these molecules structure are identical, the same. To make a long chain, we put these molecules together and they form a long chain, and generally this polymers has made. So these identical structures as a unit made up of two or more molecules join together to form a long chain. Suppose we have two small molecules which having identical structure and we put together and we join them, and again we join another molecule, and again we join another molecule, and this process continues for some time, and gradually a long chain formed when these molecules join together, obviously by the help of different polymer processing technique. So in this way we can make different polymers. So now I hope you have understood what is polymer, what is the meaning of that, and how this polymer we make. So next, different characteristics of polymers. So the majority of manufactured polymers are thermoplastic. So generally the polymers which we make, which are manufactured, they are thermoplastic type polymers. Okay, so what do you understand by this thermoplastic polymers? So thermoplastic polymers, it means is that once the polymer is formed, it can be heated and reformed over and over again. So this is very interesting that if you manufactured a thermoplastic polymer and after some time, after some application, you feel that you need to reform it, you need to reform, and you need to add some properties, or you need to improve that polymer, then you can make it by heating that polymer, and by going through different processes we can reform that thermoplastic polymer again and again. That's why it is very much interesting that the majority of manufactured polymers are thermoplastic, meaning that once the polymer is formed, it can be heated and reformed over and over again. You can heat that thermoplastic polymer and you can reform it again and again. This is very interesting characteristics of thermoplastic polymer. So as this thermoplastic polymer can reform again and again, this property allows the polymers, allows the, or we can say allows thermoplastic polymer for easy processing, as well as we can recycle this type of polymer. we can recycle thermoplastic polymers and we can easily process them. And there are another type of polymers which are called as a thermosets. So these thermosets polymers, they can't be remelted. They are different than thermoplastic. So thermoset polymer, once these polymers are formed, reheating will cause the material to ultimately degrade but not melt. What happened in thermoplastic? If it once formed, we can again heat it and we can reform it many times, repeating times. But in case of thermoset plus polymers, if you heat that after it formed, if you again reheat them, they will not get melted. Instead of melting, what happens? Their properties will get degrade. Their properties will reduce, but you can't reform them. So these are the two important polymers and its properties, its features, how they react upon heating. So overall, every polymer has very distinct characteristics. Each and every polymer having different characteristics, but most of the polymers have these different attributes, different features, different characteristics. Okay, like polymers can be very resistant to chemicals. They are very resistant to chemicals, means they are not easily they can react with chemicals. This is the characteristic of polymer. Polymers can be both thermal and electrical insulator. Polymers can act as an insulator in both thermal and electrical field. Then generally polymers are very light in weight with significant degrees of strength. Though your polymer is very lightweight, but they have high degree of strength. Means weight to strength ratio is very high. So you may feel that this if you take a polymer, it is very much lightweight, but very high strength it can possess. Then again, polymers can be processed in various ways. You can process polymers in various ways. Polymers are materials with a seemingly limitless range of characteristics and colors. These are very much interesting thing that polymers, their characteristic, their features is very large, and we can get polymers in different colors which widen their applications. Then polymers are usually made of petrol but not always. So generally this polymer we make it using different types of petroleum, okay, generally, but in other way also we can process this polymers. So generally polymers are made at those cases where there are no alternatives, because many materials, simple materials, common materials, they have very limitations. So if you want to make such material which are very much specific applications, we can make using polymers. That's why it is written polymers can be used to make items that have no alternatives from other materials. But the advantage of polymer, there are different disadvantages are also there. They have very poor mechanical properties. Their mechanical properties are very poor. This is one disadvantage. But there are many other advantages also, like they are very much economical. You can get excellent surface finish. So in some cases where surface finish is very much important factor, in those cases we can use polymers which can produce very much high level, high degree of surface finish. So our next part is types or classifications of polymers. Okay. So as you know that polymers are numerous in numbers. Very different types of polymers you can get, and different behaviors, different properties they can give you, they can show. So this classification is very much widened, and these polymers, the interesting thing is that these polymers we can find in nature, or you can say naturally found polymers are there, as well as synthetically or by different artificial processing, by following different processes. Synthetically also we can create different types of polymers. That's why this classification of polymers is very much widened. But in basic we can uh, classify these polymers in two ways: classification based on source, classification based on source, how or from where you are getting the polymers. This is one classification, classification based on source. Another is again polymers can be classified based on structure of polymer. What is the structure of your polymer? Based on that also we can classify. Then another classification method is mode of polymerization, means how we are making those polymers. What is the process? Depending on different processes, uh, polymers can be classified. Then another way we can classify polymers is the classification based on molecular forces. In this four category we can classify our polymers. So first classification. So again I am repeating what are the different way we can classify polymers. First in classification based on sources, classification based on structure of polymers, classification based on mode of polymerization, means how we are making those polymers, and fourth is classification based on molecular forces. These four categorized way we can classify our polymers. So first classification based on sources. Okay. So first classification based on source. So class, as I already told that polymer it can be found from naturally, or you can say by artificial processes. So in that way we can classify polymer like based on source of origin. So there are two types, or we can say two subtypes of polymers. First is natural polymers, then synthetic polymers. So what is natural polymers? It is the easiest way to classify polymers is their source of origin. Natural polymers are polymers which occur in nature and are existing in natural sources like plants and animals. So those polymers which are naturally available, naturally from different types of plants, different types of animals, you can get this type of polymers which are known as natural polymers. So one example is given here. Like some common examples are protein, different protein, which we can found in human or animal. Okay. Then we also can found cellulose or rubber or starch in different plants, okay, or different tropical plant. So these are the natural polymers. Then synthetic polymers are polymers which human can artificially create, synthesize in different laboratories. Means they are commercially produced by industries as per our requirements, as per our necessities. So synthetic polymers are artificially created by different industries for human necessities. So different examples are like we are using in our day-to-day life polyethylene or nylon fibers, which are using in different cloths, different fishing nets, etc. These are the artificial polymers or synthetic polymers. So polymers can be classified in based on their sources, and it again can subdivide like natural polymers and synthetic polymers. Then again another way it can be possible like semi-synthetic polymers. So semi-synthetic polymers are polymers obtained by making modification in natural polymers artificially in a lab. So semi-synthetic polymers are polymers which are obtained by making different modification in natural polymers. Like here we see that there are natural polymers are there. So if we do some modification in those natural polymers in artificial way, then we will get semi-synthetic polymers. So these type of polymers are formed by chemical reaction in a controlled environment, and are of they have different commercial importance. Like generally we get rubber, you know. So we process that rubber in different, and we place them through different chemical reaction, okay. Then this natural polymers they becomes vulcanized rubber. So this is semi-synthetic polymers where we uh, do some modification of our natural polymers. So next classification is based on the structure of polymers. As per the structure of polymers, we can classify our polymers. So this classification based on structure of polymers, it can be of three types. First is linear polymers, branch chain polymers, and cross-linked or network polymers. In linear polymers, these polymers are similar in structure to a long straight chain which identical links connected to each other, which identical links connected to each other. Okay, so they are long chains, single similar in structure, long straight chain, okay, with just numbers of these small polymers they linked together to form this long chain. This is called linear polymers. So these polymers have high melting points and are of higher density. These polymers have high melting points and are of higher density, like PVC. PVC, their structure is similar and it is of a long straight chain. Then we have branch type, or you can say branch chain polymers. As the name itself suggests, in itself describes that the structure of these polymers is like branches. In a tree we have different types of branches. So here also the branch chain polymer also, they are like branches originating at random points from a single linear chain. There are single linear chain are there, and from that single linear chain there are different branches coming out. So here also different monomers, they join like this way, and they form a long straight chain where there are also some branch chain are there of different lengths. Okay, and in that way branch chain polymers are formed. So as there are different branches arises from a long linear chain, so these polymers are not closely packed together. They are not branch chain polymers are not closely packed. Okay, that's why they have low density as well as they have low melting point as they are not closely packed. So one example is here LDPE, low density polyethylene. So this is types of branch chain polymers. Okay, so LDPE they used in plastic bags and different common containers. So these polymers they again can be classified based on cross-linked or network polymers. Based on structure, there is another type which is cross-linked or network polymers. In this type of polymers, monomers are linked together to form a three-dimensional network. There, like in firstly we have a linear single chain polymer, and then we have branch chain polymer where from a linear single chain we get different branches, different branch chain we get, and then branch chains again having different length which are not interconnected. But in cross-linked or network polymers, here monomers are linked together to form a three-dimensional network. So these monomers contain strong covalent bonds as they are composed of bifunctional and trifunctional in nature. Okay. These polymers are brittle and hard because they are closely linked with each other. Bakelite is the example. Then again, polymers it can be classified based on polymerization. So based on polymerization means based on the process through which these different molecules or different monomers they reacted together in any chemical reaction, and they form those polymer chain. Okay, so they based on that there are different subtypes. One is addition polymers. In this type of polymers, they formed by repetitive addition of monomers, repeated addition of monomer molecules. The polymer is formed by polymerization of monomers with double or triple bonds. Addition polymers always have their empirical formulas same as their monomer. Means whatever the formula of those monomers which added one by one and formed these addition polymers, they both of their empirical formulas are same. After addition polymers, we have condensation polymers. So these polymers are formed by the combination of monomers with the elimination of small molecules like water, alcohol, etc. So here there are very less presence of water and alcohol molecules. Okay. So in this polymers, condensation reaction has happened, which are bifunctional or trifunctional in nature. So nylon 66, these are one type of condensation polymers where molecules of water are eliminated in the process, in the polymerization process called hexa methyl diamine and adipic acid. These are the polymerization process. Okay, and nylon 66, there the water molecules are eliminated. Then the last one is classification based on molecular forces. Intermolecular forces are the forces that holds atom together within a molecule. In polymers, strong covalent bonds join atoms to each other in individual polymer molecules. So these intermolecular forces are the forces which hold, which make the atoms together. Okay, in a molecules, the force which hold your atoms together is known as intermolecular forces. So intermolecular forces attract polymer molecules towards with each other. Okay. So these based on these molecular forces, we have four types of polymers. One is elastomers, then thermoplastics, then thermosetting, then fibers. Okay. So this type of polymers, we broadly will see this type of polymers in our next classes. Today up to this, and in next classes we will see what is this elastomers, thermoplastics, thermosetting and fibers. And again we will see different polymer processing processes. Okay, this we will see. So if any student having any question, you can ask me now.